So in this video we're going to look at multiplying complex numbers in polar form. This boils down to two major transformations. Dilation, which is governed by the modulus, and rotation, governed by the argument. As an example, we'll start by looking at multiplying the complex number 3 plus 2i by the complex number I. So if we note that I can be represented in polar form as cis pi on 2, this has a modulus of 1, so in other words we shouldn't have any impact, any dilation, or the modulus of the should remain the same. The argument on the other hand is pi on 2, which will lead to a rotation of pi on 2 in an anti-clockwise direction. So as a result, I times z will give us the complex number minus 2 plus 3i. In a moment we'll look at this transformation as well as transformation by multiplying by minus 1 and minus I. We demonstrate these simple transformations in Geogebra. So the first thing we do is we enter the complex number 3 plus 2i, and from there we're going to multiply that by I. Now if we look at the resultant, which is given by z2, we can then measure the angle between those two complex numbers, and we can see there that that is 90 degrees, again confirming that we've got a rotation of 90 degrees. We can look at similar transformations. Multiplying by minus 1 gives us a rotation of 180 degrees, and multiplying by minus I gives us a rotation of minus or 270 degrees, or minus 90 degrees. Last thing we look at here is showing that the modulus of each of these values remains the same. And we can see that here they're all equal to approximately 3.61. We now look at a second example of multiplication, this time looking at multiplying two numbers in polar form. So if we multiply z1 by z2, then we note we group the moduli together, and then we use our rule which allows us to add the two arguments together. We get a result of 6 cis 7 pi on 2. Converting that into degrees, we notice that should be equivalent to. We now use Geogebra to demonstrate the multiplication of two complex numbers in polar form. So we begin by entering the complex numbers using Euler's form, and we draw our vectors from the origin to the complex number, and then measure the angle, or the argument. We enter our second complex number in polar form, again using Euler's form. So this time 3 cis pi on 3. Again we draw that in vector form, measure the argument, this time of 60 degrees. And then finally we multiply the two complex numbers together. And we see here we get z3. If we measure the angle, we get an angle of 105 degrees, which corresponds to 45 plus 60. Looking at the moduli of each, first two are 2 and 3, we notice that 2 multiplied by 3 gives us the modulus of 6 for our result. And we see if we move our complex numbers around, we get similar results.